Morning everyone. Myself Priya, Assistant Professor, Department of Computer Science. In this video, I am going to teach you a concept in the subject operating system. The topics I am going to cover are free space management and its methods, and the last is file access methods. First we will see about free space management. When the files are newly created, the system allots memory spaces for that particular files. Therefore, the system keeps track of the free disk blocks for allocating spaces to the newly created files. Also, when the files are being deleted, the spaces allotted for that particular files are released and it is allotted to the newly created files or directories. Hence, the system maintains a list of free spaces and also it keeps tracks of the disk blocks that are free. That is, the spaces that should not be allotted to any other file or directory. The free space list can be implemented in 4 ways. They are bitmap or bit vector, linked list, grouping and counting. First we will see what is bitmap or bit vector. So a bitmap or bit vector is a collection of bits where each bit corresponds to a disk block. Here the bit can have two values, either 0 or 1. Here the value 0 indicates that the block is allotted to some file or directory. The value indicates that the particular block is free at that particular moment. Here I have an example, a bitmap of 16 blocks. Here I have 16 blocks. The blocks which are green color represents that it is allotted to some files or directories. The blocks in white color represents that it is free. So as I told already, the value 0 indicates that the block is allocated, whereas the value 1 indicates that it is a free block. So here the bitmap has the value 0, 0, 0, 0, 1, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1, 0. That is, the block allotted represents the value 0. The block which are free is represented as the value 1. So the advantage of bitmap or bit vector is it is very simple to understand, and also finding the first free block in the disk is very efficient. But it requires scanning the words in a bitmap for a non-zero word. That is, it scans to find out the first free space that is available in the disk. Also, here the bits may consist of a value either 0 or 1. The block number can be calculated. That is, the first free block is then found by scanning for the first 1 bit in the non-zero word. So the block number can be easily calculated as a formula, that is number of bits per word into number of zero values words plus offset of bit first bit 1 in the non-zero word. So when we scan the bitmap sequentially for the first non-zero word, first we have to group the bits into 8 bits. So in the example, I have taken the first 8 bits. Also in this 8 bits, it does not constitute a non-zero word since all the bits are not 0. So when the non-zero word is found, we look for the first 1 bit. So this is the fifth bit of the non-zero word, that is the value is 1. Hence the offset value is equal to 5. When we substitute the values in the above formula, the first free block number is equal to 8. That is, the number of bits per word is 8 into number of zero values words is 0 plus the offset value, that is the fifth bit of the non-zero word, that is the fifth bit value is 1. Therefore, the offset value is 5. So 8 into 0 is 0. 0 plus 5 is equal to 5. So the first free space is fifth disk block. Next method we are going to see is linked list. Here the free disk blocks are linked with each other. That is, the free block contains the pointer of the next free block. So the free blocks are linked with each other. Here the block number of the first disk block is stored at the separate location on the disk, and it is also cached in the memory. So here is an example of linked list. So here same, the blocks that are in green color are allotted, whereas the blocks in white color are free. Here block 5, block 6 and block 7, block 14, block 15 are free. Here the free blocks are linked with each other. That is, block 5 is linked with block 6, then block 6 is linked with block 7, then block 7 is linked with block 14, and the last is block 14 is linked with block 15. So the first free space is block 5. So that is the free list head, since it is the first block that is free. So in the above figure, the first free space is list head point to the block 5, which links to block 6 and so on. Also, the last free block will contain a null pointer that indicates the end of the free list. For example, in this example, block 15 will have a null pointer that indicates that this is the last free block. But it has a drawback, that is, for traversing the free space list, it is needed of IO operation. So it requires an IO requirement for traversing the free space list. Next method is grouping. So grouping method stores the address of the free blocks in the first free block. So in the first free block, the number of free blocks, that is, there may be n free blocks. So the n free blocks informations will be stored in the first free block. So also, out of these n blocks, the first n minus 1 blocks are actually free for allocating to the files or directories, whereas the last free block will contain the address of the next free n blocks. The advantage of the grouping method is that the address of a group of free disk blocks can be found easily, since the informations of all the free blocks will be stored in a particular block. Next, we are going to see about counting. Counting approach stores the address of the first free disk blocks and also the next free contiguous disk blocks that follows the first block. So here in this counting scheme, the address of the first free disk block is also stored along with the number of continuous free disk blocks. For example, in the first free place, the address of the block 5 will be stored, and also there will be a number n. Here we have number 2, that is, in the address block of 5, in the disk block 5, additionally the next 2 contiguous free blocks will be followed from the block 5. That is, here block 5, block 6, block 7 are free. Next, we are going to see about file access methods. Actually, when a file is being used, the informations are either read or write in the computer memory. Also, there are several ways to access the content of the file. Some system may provide only one access method for file operation. Such systems, for example, in IBM, access methods for choosing the particular application for accessing the file is the major design problem. In general, there are three ways for accessing a file in a computer system. That is sequential file, direct access and index sequential method. So the file access methods are sequential access, direct access and index sequential method. So first we will see about sequential access. So sequential access is the simplest method. The informations in the file are accessed in a particular order, that is one by one. The informations are accessed in a order, first record, second, then third and so on. So this access is most common. Also it is, for example, the editor and compiler usually access the file in this sequential access order. Also a read operation, that is it automatically advances a file pointer which tracks the IO operation. Similarly for write next operation, the end of the file advances to the newly written material. Next is direct access. So direct access method is also known as relative access method. So here the informations in a file can be read or write randomly. It does not follow any particular order. So it is based on the disk model of the file, and also disk allows the files to be accessed in a random access. That is, for the direct access, the file can be viewed in the form of number. So each sequence of block will have a specific unique number. So depending on the number, the files can be easily accessed. So a file can be accessed by using its index number. There is no restrictions in the order of either reading or writing for a particular file information. So also it provides the user with a block number for easily accessing the file. Next is index sequential method. It is the other method for accessing a file, which is referred as the top of the direct access methods. These method actually have an index number for the file. Similar, if we, for example, in a book we have index for easily identifying the content in a particular book. Similarly, here to access the records in a file, we first search for the index, and the help of the index we access the file directly. So as I told already, it is built on top of sequential access, and also it controls the IO pointer by using the index value. Thank you.